Good afternoon, everyone, and welcome back to your Algebra 1 boot camp. Today, we are going to be talking about how to factor quadratic equations. So let's go ahead and start with a little warm-up. Picture below, we have a quadratic function graphed, and it wants us to identify the zeros of the function. So we're going to look here where it intersects the graph at the x-axis. And looking at our scale, so this is 2, this is 4, so therefore this is -5, 0. And again, this is 2, so therefore this is 1, 0. So the zeros are -5 and 1. The intercepts are the points. The zeros are the x values. Today, we will factor trinomials and solve quadratic equations so that we can find the roots, solutions, or zeros of the quadratic function. We'll know we have it when we can factor and solve quadratic equations algebraically and using Desmos. So let's start with a little bit of a review. What is a factor? What does the word factor mean? A factor is one of two or more numbers that divides into a number without a remainder. Another way to say this is every number that a number can be divided by. Okay, so let's start with our first number. So I'm going to pick the number 20. Okay? They told us 3 times 2 is 6. So 3 and 2 are the factors of 6 that they used. But let's say they wanted all the factors. So we have 20, and then we can just name the things that can go into 20. So 1 and 20, 2 and 10, 4 and 5. Now we would be circling back around. Okay? These are the factors, the numbers that we can multiply together to get the answer we're looking for. In Algebra 1, factoring an expression means to break it down into its smaller pieces. So just like I factored that number, I broke 20 down into its smaller pieces. We can do the same thing for our quadratic expressions or any larger expression most of the time. So in this example here, we are given the expression x squared minus 3x minus 40, and we are told it breaks down into the factors of x minus 8 and x plus 5. So we're going to go and look at this slide in our Amplify assignment. And it wants us to click on the x-intercepts of the parabola, which is, of course, as we said yesterday, is what we call the shape of the graph of a quadratic function. And I just like to label them so I can see them. And then it wants us to move the slider until until the line is at the intercepts. And we want to look at what do we notice. So when we intersect here, we can see that when a is -5, x is -5 here. So we can move that. It's a linear function. And we can do the same thing on this one. We can take the linear value function, put it through the point. Okay, so we can do the same thing for all of its factors. So if we were to take x minus 8, which is how we would get a equals 8, why does a equals 8? Because that's where y equals 0. So if y equals 0, and the equation of, say, this blue line is y equals x minus 8, what we are going to do is we're going to set x minus 8 equal to 0, add 8 to both sides, and that's why x is positive 8 here, okay? So this is x equals 8, and this was x equals -5. And again, we could say that for the same thing with the a value. Pay attention to the fact that the signs inside the parentheses is the opposite of what the actual 0 is. Another way to check our work on this, instead of having the straight lines, is to graph the expression in factored form so that the graphs overlap. So let's go ahead and see what this looks like live. Okay, so we are continuing to look at the expression x squared minus 3x minus 40. And then we're going to write it in what we call factored form. What that means is we're going to write the factors that we determined. So x plus 8 and x minus 5. Oops, I did it wrong. Okay, and you see how the graphs don't overlap? That means I'm wrong. We actually had x plus 5 and x minus 8. And now you see how I covered up the red graph with the blue graph? Now they are the same equivalent expression. So if I turn off the blue graph, you can see the red graph alone. Turn it back on and off, on and off. This is how we would check answer choices in order to see which one we're going to pick. We can graph the expression they want us to look at and then all of the answer choices. We can do them all at once or one at a time. All right, so let's look here. We have what are the factors of x squared plus x minus 6? All right, so again, let's go ahead and start by putting in our first one equation, x squared plus x minus 6. Now, I should always remember that I do have this written on the side over here. Right? Our first answer choice is x minus 6, x plus 1. And we can see those are not the same graph. Look at that blue one. It's way crazy. Okay, we had x minus 2 and x plus 3. And we can see now that we already have one that's covering up the red graph. We can see we can turn it on and off. It should at least look like it's flashing. Okay, so I'm going to turn off the blue one. Now, just to be safe, we can always try our other answer choices as well. So we had x plus 3, quantity squared, and we had x minus 3 squared. All right, so we can see that the only one that matches the red one is the green one. Now, could we have simplified and decided which ones we didn't even need to check? Yes, by looking at what the last two numbers are and seeing which ones multiply to give us negative 6. So this would be x plus 3 times x plus 3. 3 times 3 is 9, which is not negative 6. Okay, this one is negative 6 times 1, negative 2 times 3, and this one was negative 3 times negative 3. So these two both could give me negative 6. So when I did this in the live class, we didn't actually check these two answer choices. And our correct answer was x minus 2, x plus 3. Okay, so let's use that same logic and determine what we can get rid of, just without even knowing anything about how to factor. We want to know which expression is equivalent to 16w squared plus 24w plus 9. So let's look here. We have 4w plus 3 and 4w plus 3. So we have 3 times 3, and that gives me positive 9. So again, we have negative 3 times negative 3, and that also gives me positive 9. And then we have again 3 times 3, and that's giving me 9. So again, all of these, we can see that they only all give us 9. So let's look at the first terms, see if we can eliminate any there. This is a testing strategy. So we have 4w, we have that squared. That is 16w. So we have the same thing for both of the first two. However, 8 squared is 64. So it would be 64w squared. So we know we're not going to check this one. I'm not going to check this one. I'm only going to check these two because the first and last terms can exist based on what little I am pretending to know. Okay. Now I'm going to go ahead and do the switch it into x just because I think that's more effective. Because you have to put in another variable. Seems so 16x squared plus 24x plus 9. And we had 4x plus 3 squared. And we had 4x minus 3 squared. Okay, so which one is covering up the red one? It is the blue one. So the answer is 4x plus 3 squared. Okay. The area of a rectangle is 6x squared minus x minus 12, and the width is 2x minus 3. So we want to know what is the length. We know that area is equal to length times width. They gave me width, so I'm looking for length. Length is equal to area divided by width. So we have 6x squared minus x minus 12, and we're going to divide it by 2x minus 3. Okay. Now, how are we going to do this? Well, we're going to graph it. There's a couple of things we can do to eliminate answer choices here as well. So what I'm going to do is tell you that we can figure out what the zeros are from here. And that is by taking any binomial. So let's see, a x plus b. If we take the opposite of the back, the front, we can get what the zero would be. So it's going to be the opposite of the back would be 3 over 4. This is going to be negative 3 over 4. This is negative 4 over, sorry, positive 4 over 3. And this one is negative 4 over 3. So this is going to let me know which ones I want to check. I can check my zeros. Again, this is just a testing strategy. If you aren't familiar with this rule, will it matter if you check all of them? No. Okay. So go ahead and check them all if you need to. All right, so I am going to clear this, and I'm going to say 6x squared minus x minus 12, and we are going to divide that by 2x minus 3. Oops. And that gives me my linear factor, which was at 1.5. So let's look at this one. We have negative 1 1/3, 1.333. So we can see that the answer that would give us the negative 1.3 is 3x plus 4. So now I only have to check that one. So I'm going to say 3x plus 4, and that goes through my linear, or that is a linear factor of this quadratic. But if we didn't remember, we could again always go 3x minus 4, 4x plus 3, and 4x minus 3. And we could see, I would just turn off all of them and turn them on one at a time and see which one goes through the point I'm looking for. Okay. All right, next problem. Which expression is a factor of x squared minus 10x minus 24? Again, this one doesn't give us much to check with to start. So let's go ahead and start by graphing the original expression of x squared minus 10x minus 24. And I'm going to zoom out a little bit so I can see both parts. And again, I can use this information if I want to narrow down what I'm going to try. So I have 12 and negative 2 as my zeros. So I can look and see if there's anything that would make it easy for me to check. So let's take a look. I'm going to guess it's not negative 6. I'm going to guess it's not -4 because neither of these numbers are 12 or 0. So my first ones that I am going to check, and if they work, then great, is the x plus 2 and the x plus 12. Okay? Those are the ones I'm going to check first, and that's to keep it simpler. So we have x plus 2, x plus 12, x plus 2 is the one that goes through the point, and so therefore that's the one we're going to put as our answer. So we had decided that we discovered the answer was x plus 2. Right, we can look at this graph right here and see what things we notice. I will tell you that in live class time, one thing they noticed is that it's very skinny. They noticed that it hugs the y-axis. But the most important thing that they noticed is it does not touch the x-axis at all. Okay, so what does that mean? Well, it means there's no real solution. There's no real factor. There is no line that I can draw through and match it at the x-axis because this one does not touch the x-axis. Okay, so again, here we see this graph right here that does not touch the x-axis. So there are no real solutions, no real factors. So let's go ahead and summarize what we were talking about today. You can use a graph to identify all factors of a quadratic function. You can graph both the problem and each answer choice until you find the match that works. You should probably change the variables to x. That does make it more effective so you don't have to type y equals or f of x equals. If you're using something other than x, I believe you have to use another variable in there. I haven't been able to make it work without a variable, but it always works if you use x. Use the graph to find matching to find one factor if you're given one factor. Easy enough. You just type in the equation first and the factor they give you, and then the answer choices. You can either do that one at a time and find the linear matches, or write it in factored form by multiplying the two factors together. You can use a graph and a linear graph if you're identifying just one. You would graph both the problem and then the answer choice until you find the line that goes through one of the x-intercepts. So let's look at our exit ticket for today. It was x minus 5 times x plus 8. And what is that going to be equal to? So let's first go ahead and graph those. First of all, if you have a factored form, if you can write it in factored form this way, by default, it has a solution. So it can't, well, it can be none of the above, but it will not be none of the, it would never be no real solutions if it is in factored form, okay? Another thing we can look at is what do these first two terms multiply to? That's not 2x squared, that's x squared. And what do these last two terms multiply to? Even if we can't remember the whole thing, that's negative 40. So I can logically say there's something between an x squared and a negative 40, and it probably will be x squared plus 3x minus 40. That's a good way to check. And of course, you can always do all of them. So we have x minus 5, x plus 8, and then x squared plus 3x minus 40. And we can see that that overlaps. So therefore, that is our answer. All right. Thank you for watching, guys. Make sure you review this. It's slower if you need to. Copy the notes, get some practice, and we know you're going to do great on the STAR. Bye.